Before we start constructing our own Punnett square class, so let me introduce to you first the inventor, the inventor of your what we call as Punnett square. So he is Mr. Reginald Crandall Punnett. Okay? Remember his name. So he was one of the first English geneticists that created the Punnett square. So the Punnett square. This is used to determine the possible allele combinations or genetic combinations of the offspring pair. Okay. Again, so Punnett square is also used to predict the genotype and phenotype of any offspring. So by just constructing, okay, so this diagram that we have here is an example of Punnett square. So we can determine the genotype or the genetic composition of an offspring as well as its phenotype by merely solving Punnett square. So in Punnett square, what we're going to do is just to fill in these diagrams with the variables that we have in the problem. Okay. All right. Okay. So here is a step on how to construct a Punnett square class. By the way, so first, what you need to do is first to determine the genotype of both parents. So you might be wondering, how do we even determine the genotype of both parents? Well, of course, when solving problems in the Punnett square, so your teacher will give you the genotype of both parents or the genetic combinations of both parents. Or in a world problem scenario, so I am going to, for example, give the phenotype of only the phenotype of the parents, and it's you class who is going to determine what is the genetic composition of both parents by analyzing the phenotype of both parents. Okay, so let's use this one as an example. Okay, so again, step one, determine the genotype of both parents. Okay, so here's a sample problem class. So cross capital A, cross AA and AA. Okay, this one. We're going to cross this one with this one. So wherein your capital letter A, the dominant gene, is normal, and your recessive allele or the recessive gene is albino, which is your small letter A. Okay. So now, again, our first step is to determine the genotypic composition of both parents. So we already know what are the genotypes of both parents, and that is this one, capital A small a and capital A small a. Okay, so basin ito yung or ganito yung genotype ng parent. For example, the mother, and this one is a genotype of the mother. For example, pasa. Okay, so since kaybaw na ta, or since we already know the genotype of both parents, we immediately proceed to step number 2. Okay, here's your step number 2 class. Okay. Segregate the genotypes to represent azygotes. So this time we are going to apply the law of segregation from the 3 laws of genetics. So how do we do that? How do we segregate? How do we segregate both? How do we segregate the genotype of both parents? Since this one is we understand that this one is the genotype of both parents. So to segregate it, ani rin siya classes. So just write down the capital letter A on this area, and the small letter A on this area for, this is the genotype of one parent. And then the next one, all we need to do is to write that one down here. Okay? Nanara na siya mag-segregate sa genotypes of both parents. Okay? In monohybrid cross. By the way, class, so this problem is an example of monohybrid cross because we call it monohybrid cross because we are only trying to cross one trait. So if duha na ka-trait, if duha na ka-trait or dalawang traits na yung i-cross natin, so it is already called a dihybrid cross, and if tatlo, it's trihybrid cross. So the more traits that we cross, the more complex or the more difficult it is to cross, no? So sa monohybrid cross, since we are done segregating both the alleles of both parents, so let's see, we can now proceed to step number 3. Okay, using the product rule, cross multiply the gametes. So in this case, since we are using Punnett square, all we need to do is just to i-connect reta ni sila sa like for example, if we are going to multiply the letter A here and the letter A here, so what do you think will be the answer? So the answer would be 2 capital letter A's. Okay, very good. Yes, very good. So mauna siyang answer. So, and now if we're going to cross this one and this one, okay, so the answer would be capital A and small a. So, kung asa ganito na capital, maula to atong iunag suwat para di ka mag-iibog, no? Okay, so again, if we are going to cross this one with this one, so the answer would be capital A and small letter A. Okay, same goes with this one. Okay, if we are going to cross capital A and small letter A here, or the dominant A and the recessive A, okay, so we will have capital A and small a, and if we're going to cross both recessive alleles, so understood na siya nga homozygous recessive. Okay? Yes, very good. Sakto. AA. Okay? Now, since we are done applying step number 3, we are now going to proceed with step number 4, is to write down the offspring's genotype and phenotype. So how do we know, or how do we determine the genotype and phenotype of their offspring? So to determine the genotype and phenotype of both offspring, all we need to do is just to count the possible allele combination, or we are going to count the allele combinations that we see inside the square. Okay, so let's go first with the genotypic ratio. So again, class, we're going to count.
Sir, excuse me, sir.
Yes.
Dili ko ana, sir, kanang recessive. Ang ka-fourth one.
Kini. Automatic mo capital siya basta o kanawa. Basta recessive, basta small letter and small letter both are, if we're going to cross both recessive alleles, of course, yung product is recessive both na ano ra siguro sa pag-type, like automatic siya makapital ba? Capital letter ba? So, mo na siya. Okay, so to determine the genotypic ratio of this cross, so again, we are going to count the possible allele combinations that we have inside the square. So one combination we have is the homozygous dominant A. Okay. So how many are there? How many homozygous dominant A that you see inside the square? So Sarah, di ba? Kani. So we only see one homozygous dominant combination inside the square. So markahan na lang siya. So we have one. About the heterozygous combination, so we have Tuha, 1 and 2. Tuha, okay? Markahan na siya para di ka malibog. Okay, so we have 2, and then for the homozygous recessive, we only see one of it inside the screen. Okay, so the answer for the genotypic ratio is 1 is to 2 is to 1. So mauna na siya. Okay, so this is already the answer for the genotypic ratio. 1 is to 2 is to 1. Or you can also use as an answer, you can also use fractional form as an answer for the genotypic ratio. So since we only see one homozygous dominant A's on the square, we can say that it's 1/4, no? 1/4, and since we also see two heterozygous combination, so we can say that it's 1/2, and then for the homozygous recessive, so we can also say that it's 1/4. Or you can also use the percentage form as an answer, since there is one homozygous dominant A, so we can say it's the probability is at around 25%. For heterozygous combination, we can say that the probability is around 50%, and for the homozygous recessive, 25%. Okay, so that is for the genotypic ratio. All right. Now for the phenotypic ratio, so phenotype dyan in class is the observable trait of a certain organism. So from the combinations that we have inside the square, so we will now determine the physical appearance or the phenotype of their offspring. So our possible phenotypes will only be normal and albino. Albino is a genetic disorder in which our body cannot produce melanin pigments. So very rare. This is a very rare genetic disorder. Okay, so it is also possible with animals like rats. Permanent na siya makita ng mga mouse, ng puti na mouse. Sa carabao, I don't know if you have seen a carabao which has an albinism, and then of course humans. It is also very possible in humans. Okay, so our possible phenotype is normal and albino. So based on the possible combinations that we have here. Okay, so if in any class ang genotype sa genotype sa offspring, what do you think is the phenotype? Possible phenotype of their offspring if he or she has this genotypic combination. Okay, so so again sa law of dominance, if you can see one dominant allele in the genotypic combination of a certain organism, the organism will manifest the dominant trait. In this case, normal. So since homozygous dominant siya, understood na siya na normal ang bata or ang offspring. Okay, so we have already one. And if the phenotype or the genotype of an organism or of the offspring is this one, okay, remember law of dominance. If na one dominant allele that will appear on the genotypic combination or in the genotype of that certain organism, the organism will manifest the dominant trait, but will become a carrier of the recessive trait. Okay, so if inani ang genetic combination, inani and inani, so we can say, okay, so dominant, since na siya dominant allele, so normal pigmented siya. So our answer would be 3 here. And for albino, since we only have one homozygous recessive in our combination, so the answer would be 1. Okay. So our phenotypic ratio would be 3:1, or in fractional form, we can say 3/4 to 1/4. 3/4 is 1/4, or in a percent form, we can say 75% normal and 25% albino. Okay? Any question?
None, sir.
Question? Wala? Nakuha ra ninyo?
Yes, sir.
Sure ha? Sige. If wala na may question, let's proceed. Right, so let's proceed to problem number 2. So problem number 2, this time we are going to cross 2 traits now. Okay, like problem number 1, we only use 1 trait and we only cross 1 trait. This time we will use 2 traits we are going to cross 2 traits. Okay, and this is an example of a word problem in solving Punnett squared class. So nanini siya. Okay, so the problem is that Kim and John is planning, or are planning to have a baby, and they want to know the probable traits that their baby should have. Kim has black and curly hair, moni and genotype, or genotypic combination, and her husband also has the same type of hair. So black and curly, both C husband or C John. Okay. So the allele representation. So B for black, capital B for black, and the recessive B for blonde, and then for capital C, or the dominant C, will be curly, and the recessive C will represent the straight. Okay, so recessive ang blonde, recessive ang straight, dominant ang black, dominant ang curly. Okay, so remember the first step in constructing a Punnett square. So number 1 again, determine the genotype of both parents. So what do you think is the genotype of both parents? Okay, so the genotype of both parents is this one. So for Kim, here is her genotypic combination. So then for the husband, that's also the same. Okay. And then once we know the genotype of both parents, we will now proceed to step number 2 to segregate both alleles. No, so how are we going to segregate both alleles in a dihybrid cross? Diri na nag-start na medyo nagka-complicated na dihybrid cross. So first, in order to segregate the alleles of both parents, so what we need to do is to akong diskarte is butangan ako siya parenthesis na lang. I am putting a parenthesis, open close parenthesis, close parentheses, meaning we are going to multiply we're going to use product rule on this combination OSA. Okay, right. So we are just going to use the FOIL method for us to separate the alleles of both parents. So FOIL method stands for first term, outer terms, inner terms, and last term in your algebra. So okay, first we are going. So now let us segregate both alleles. No? So capital B times capital C is capital B and capital C. Yan na ang iyahang so inan na ang answers. And then so for the outer terms, we have capital B and small c. Okay, so so that would be the answer. And then the inner terms, that's small letter D and capital letter C. And for the last term, both small letters B and C. Okay. Since both parents have the same genotype, we can just copy what the information that we have above, since same raman ilahang genotype. But if they have different genotype, for example, lang genotype kay capital letter C ni siya, so we are still going to use a product for us to determine the variables that we need on this side. Okay? So, and then since we already segregated the alleles of both parents, next thing, okay, so the next thing that we're going to do is to cross. Okay, so we are going to cross this one with this. Okay, so the answer would be both the capitals BB and capital CC, or dominance BB and the dominance C and dominance C. Okay. Okay. The variables that we have here and this one, this one. Okay. So that would become 2 dominant B's and 1 dominant C and 1 recessive C. Okay. Right, next, for this one and this one, we have capital B, small b, then 2 dominant C's. And the last one, anak siya. Nakuha ra?
Yes, sir.
Okay, so proceed ka. Okay, so let's proceed. So if we're going to cross this and this, so we have and here we have 2 dominant B and 2 recessive C's. Okay, here we have one dominant B, one recessive B, and one recessive C, and one dominant C, and one recessive C. And for this, we have one dominant B, one recessive B, and two recessive Cs. Okay, so ansiran ko na lang ni kanan ha. Yan na siya. Okay. Would be the last one. Okay. And for our last column, we have A, and then for the last column, so this one and this one, for the last two boxes, so we have two recessive B, one recessive C, and one recessive C, one dominant C, and last one are all homozygous recessives, homozygous recessive B and C. Okay. Now we are done filling all of the blank boxes in sa atong square. So so the next thing that we're going to do is to determine the genotypic and the phenotypic ratio. Okay. So here is the phenotypic and the genotypic ratio, by the way, class. So these are the possible combinations that we can see inside our square. Okay? Di ansiran lang na ako kay if na ako ansiran daan murag madugay ta. So okay, so mao ni siya. So by the way, I will be sending this one to you later on, so you can also review if sakto ang na-delivery sa table, but I'm 100% sure that all informations that I have here are correct. No? So, ako should be siguro. Okay. So, for the wala siyang arrange o tarong din. So, for this combination, we have 4. We can count 4 of these one inside the square. So, that is 25% already. And then for this combination, we can see 2. And for this genotypic combination, we can see 2, and so on and so forth. So, kaning mga dere, kausara ni siya nato makita sa square. So, our genotypic ratio would, so that means our genotypic ratio would be 4 2 is to 2 is to 2 is to siya. Muli siyang answer sa genotypic ratio. Okay? And for the phenotypic ratio class, okay. Okay, so for the phenotypic ratio, I already have that one written here in the tables. Okay, so let us count how many are black curly in our combinations that we have here. So black and curly. So we have this one can be considered black and curly. This one as well. This one. Okay. This one. Okay. So kani, and kani. Okay, and of course this one. Okay, so these are your black and curly combination. That is why we have 9 in total. So ano ran ako ha, I will highlight this one. Gamitan na ito color. Okay na nila. Okay, so the blue colored ones are highlighted. So meaning their phenotype would should be black curly. Okay, and then for the next one we have black and straight. There are only 3 in our combination, in our Punnett square. So let's find the black and straight. Okay, so this one can be considered as black and straight. So let's use a different color. Okay, so let's use this, and of course this one will be considered as black and straight. Okay. For blonde and straight, we only have 3 in our combination. So let's verify. So blonde and curly. Blonde curly. This one is blonde and curly. Okay, so let's use a different color. Okay, black and curly. This one is also black and curly. Okay, and we only wait. Duha lagi ni. Wala na ko na-update sa ihap. And the last one is blonde and straight. So we only have 1. So mauna siya ang phenotype niya, the 1. So that is the phenotype of possible phenotype in our combination. So the phenotypic ratio would be 9. 9 is 2. 3 is 1. Okay? Yung phenotypic ratio class. So you can also use in phenotypic ratio or genotypic ratio. You can use you can answer in fractional form or in percentage form. That is fine as long as your answer is correct. In our exam, you will be marked as correct, diba? Okay, so you can again class it during our exam or even in our activities. When you answer phenotypic and genotypic ratio, you can use this one. You can use this one as an answer. You can use fractional form as an answer, or even the percentage form as an answer to your activities or exam. So, do you have any question? Any question?
None, sir.
Wala?
Sir,
How about the others? Yes?
Up sa phenotype, sir, hindi yun sa pagkuha.
Okay. So sa phenotype, since we are using dihybrid cross so I only based when nagkuha akong phenotype based sa genotypic combination niya, which is available in our square. Okay, so since mauni ang genetic combination, so for example, this is the genotype of both the possible genotype of offspring. So all you need to do now is to determine if black and curly ba siya, black and straight, blonde curly, blonde straight. So since mao man ang count sa genotype, so since kay kaibaw na ka nga magkuha sa imong phenotype, or you already know how to determine the phenotype of an offspring by just using its genotypic combination. So all you need to do is just to count. So since for example, we have some black and curly. Since we have 4 here, we have 4, okay, plus 2, so that's 8. 4 plus 2, 6, sorry. Plus 2, 8, and plus 1, so 9. So muna akong gibutang diri 9 sa black and curly. Okay, same goes with black and straight. So black and straight, color yellow. Okay, black. So this one can be considered as black and straight, and this one as well. So i-counter na siya nimo 2 sa black and straight plus 1, so that's 3. Okay, so 3 na abot ang dere. So for blonde and curly, so that's the red that was marked. Okay, so that's the red one. So this one is okay, blonde and curly, and this one is also blonde and curly. So count 1 and 2. 2 plus 1, 3. Okay, so we have 3, and last one is curly and straight. Blonde and straight. Sorry. So since we only have one in our combination, so you can answer only. So that's only one. Usara ang blonde straight sa atong phenotypic ratio. Nakuhara?
Yes,
So,
sir.
bali-add siya na.
Sir,
Okay.
sir,
Yes?
nakakay question, sir. Unsa ang pagkuha sa iyang percentage, sir?
If you want to answer this one in percentage, so ang formula na mag-answer mag percentage, kung ganahan mag percentage is 9 count. Okay, so count the number of so i-count sa ni siya nimo. So for example, pila ni siya nabuo. Let's say sa genotype. Okay, sa genotype. I-count sa nimo pila ni siya kabuo. Okay, since we have 4, so 4 ang formula would be 4. So 4 na siya. So 4 times we multiply na siya ng number of squares that we have. If dihybrid cross, the total number of squares that we should have is 1, 2, 3, 4, 16. 16 squares na, no? So, i-divide na siya nimo sa 16. I-divide siya nimo sa 16. Divide 16. Okay, let's calculate it. So, 4 divided by 16 is 4 divided by 16 is 0.25. Okay? Is equals 0.25. Then 0.25 multiply it by 100 times 100. So total ana is 25. Okay? So that's why we have 25% here. Okay? Okay, so ayan tani. So sa phenotypic ratio, our total number for black and curly hair is 9. Okay, so let's try 9 divided by 16. Okay, equals
0.56.
16 equals 0.56, diba? Then multiply it by 100, so you will get 56. 56.3. Okay, 56.3. 56 point, gano'n na siya, 56.25, pero round off round nato into 3. So, that's it. Inana siya pag percentage class if you're going to use its percentage form as the answer for your phenotypic and genotypic probabilities. Okay?
Okay, sir. Thank you.
Nakuhara?
Yes, sir.
Okay.
Sir, ikaw lang mag-provide ng dominant and recessive na mga traits pag-exam, sir.
Yes, mag-provide ko kung unsa ang dominant na trait o unsa ang recessive trait. And it is you guys that will determine the possible genotypic combination. Okay? Once we start computing Punnett square. Once we start solving Punnett square. Okay? Don't worry, class. You will know you will really know what the dominant traits and the recessive traits, because I will tell you. I will tell it to you during our exam. Okay. All right. So aside from Punnett square, class, in order to determine the genotypic and phenotypic probabilities of an offspring, we also there is one method that we also use. It is called a fork line method. Okay, wala. Hold on, I open sa ako akong PDF file. I have prepared something from you earlier. Ay, nag-lag na dyan. Kadali sa klasan, nag-lag akong gawin na cross. Dali sa dyan. Okay na. So this is an example of a fork line method class. So to be honest, this is a much more this is an easier method for you to determine the phenotypic and genotypic ratio of the offspring, since mas easier siya compared sa Punnett square, in which you are really going to count one by one the possible combinations. But here in fork line method, before we are going to proceed with fork line method, we first determine the genotypic. The genotypic combination or the genotypic ratio of every allele or every allele combinations. And this is very useful if you are going to use dihybrid or trihybrid cross. Mas madali yung ma-determine yung phenotypic and genotypic ratio in higher crosses na. For example, we also have 4 traits that we are going to cross. So an effective way to cross 4 traits is by using fork line. So I am just going to introduce this one to you last. Okay. So again, fork line method is very useful when it comes to multiple crosses. So dili ni siya magamit. We cannot use fork line method in monohybrid cross. Okay, it's impossible to use monohybrid. It is impossible to use fork line method in monohybrid cross. So okay, so here in the problem that we have here, so we will cross this allele or this allele combination or these